I try to wear the shirt from my headshot just to set expectations with folks. Hey folks, good afternoon. I'm Simon. Thanks for having me. I'm an engineering manager at Attune, a subsidiary of Coalition Insurance, and I'm here to talk about design patterns. So, what's the deal with design patterns? Well, there's a chance you've heard of this classic book, Design Patterns, Elements of Reusable Object-Oriented Software, written by our good friends, the Gang of Four. It was published in 1994. Of course, design patterns existed before this book was written. There's a rich history behind them, along with other concepts like pattern languages that we'll defer on exploring. Before we continue, here's a list of the 23 design patterns from the book. I'll give you folks, like 30 seconds to memorize them. I'm kidding, but maybe. Let's take a step back, though. So, lots of folks have opinions on design patterns, especially on the Orange website. Well, spoiler alert, I also have opinions. Some design patterns just seem so obvious or intuitive with experience. Honestly, after writing enough code, we could have organically come up with them ourselves. They just don't seem particularly novel. Then there's the fact that JavaScript, and by extension TypeScript, are dynamic programming languages. They don't have the exact same requirements and semantics for traditional design patterns as compiled languages like Java do. Other aspects, the languages themselves, also factor in, such as JavaScript being prototype-based or Java is class-based. But that doesn't mean design patterns aren't worthwhile, that there aren't at least a few worth knowing. Even if a design pattern seems obvious, there's leverage in being able to identify the pattern, even when implementing it through intuition. It lets us turn something implicit or intuitive into something explicit or systematic. To borrow Daniel Kahneman's language, we can go from System 1, which is fast and instinctual, to System 2, which is slow and deliberative. Honestly, just knowing a concept's name also gets us pretty far too. For example, it makes communicating with colleagues much easier during code reviews. That is, knowing a concept's name provides us a common language. At this point, I'm going to assume everyone's convinced that design patterns are worthwhile. Let's explore some design patterns while in the context of working as a software engineer at a direct-to-consumer e-commerce notepad store that's pivoted to selling NFTs of notepads. At this point, our hypothetical employer has done very well. We've just raised millions after the pivot. Though apparently we're in a bear market right now, we are going to respond by discounting everything by 90% until our numbers look better. As soon as our numbers look better, the discount goes away. We want to turn on and turn off this discount quickly without deploying. That is, folks on our business and product teams need to be able to remove this discount themselves. The hard part is, how do we change something without deploying? Let's take a look at tackling this situation by using feature flags. So what exactly is a feature flag? Although not a traditional design pattern, feature flags are really neat. They allow us to enable or disable certain code paths without deploying. There's a bunch of feature flag vendors out there. Choose your favorite one. Through our vendor's admin panel, you can turn a flag on or off. We're able to decouple deploying the code for a feature versus actually releasing the experience to our end users. Feature flags also allow for fast rollbacks and gradual releases. With fast rollbacks, if a feature goes wrong, we can disable it immediately. With gradual releases, we could show discounted NFTs to initially 10% of our users, then 20, then 30, and so on, over time. Let's say our feature flag vendor's admin panel looks a bit like this. Side note, I would also encourage you folks to never roll your own feature flagging service. It's just not worth it. Catch me later for that part of this rant. This is what the admin panel looks like when the flag is enabled. That is, the flag is turned on. This is what it looks like when our flag is disabled. That is, it's turned off. In this case, the actual name of our flag that we'll use in our code is Save the Business, 90% discount. Here's what our feature flagging code might look like. Let's walk through it together. We have a getPrice method that's already implemented for us that returns the price of the selected NFT. We can discount its price with some quick math. Real talk, please don't actually do this if you're ever dealing with money. Rounding is super important. Look up half-even rounding if you're curious. Here, feature flag client is an SDK that's provided by our vendor. It has an isEnabled method that returns true if a given flag is enabled and false if it's disabled. As we saw in our admin panel, the name of the flag we're toggling on and off is Save the Business 90% discount. As soon as we turn this flag on in our vendor's admin panel, our NFT's price is discounted by 90%. We hit the code in our if block because the isEnabled method returns true. As soon as we want to disable the discount, we've made our numbers, everything is good, we can turn the flag off in our vendor's admin panel. We'll hit this else block without having to actually deploy any code. So, we used a feature flag and everything was going great until our SRE team noticed an issue and they cut our celebration short, those jerks. Unfortunately, our feature flag vendor's SDK creates a new WebSocket connection every time a flag is checked. That's not good. We told the vendor they don't want to change their SDK, so now it's on us to fix this. Let's take a look at using the singleton design pattern to help us solve our WebSocket connection conundrum. The singleton design pattern allows us to guarantee a given class only has one instance, while also making that instance globally available. In our case, we want to make sure there's only one WebSocket connection created when using our feature flag vendor's SDK. Here's what implementing a singleton might look like in JavaScript, and we'll walk through the code together. We'll use a private static field named instance to keep track of whether an instance of our singleton class was already created. In our constructor method, we'll check if that field was already set. And if it was, we'll just return its value. Otherwise, we'll actually set the value to the this keyword, that is the newly created instance of our singleton class. By always returning that same initial object, we guarantee that each time we create an instance of that singleton class, it's always that exact same instance. So, let's take a look at what actually using a singleton for our feature flag client might look like, and we'll go through it bit by bit. This is super similar to our last example. We'll store the instance as a static private field and just return it when necessary. So just like before, we're guaranteed that there's only one instance of our feature flag client at a given time. In this case, we'll also initialize the vendor's init flag client method and store a reference to it via a private instance field. This way, we won't create a new WebSocket connection every time we initialize the feature flag client. We're able to use that same vendor client reference in our instance methods too. Every time we check if a flag is enabled, we're using the same initial WebSocket connection. Although we used a feature flag vendor's SDK as an example here, singletons are honestly just worth keeping in mind whenever there's access to some shared resource, whether that's a file, a database, a cache, and so on. All right, so turns out discounted NFTs are good business. You know, go us, making good choices. Unfortunately, now we have performance issues and we just can't win. So to get around this, we'll need to selectively instrument our code to investigate these performance issues and see what's going on. That is, we need to add observability. For example, we used a getPrice method from before. Let's take a look at what its actual implementation might look like. It appears our NFT's price is based on 3 functions. We get the version of the NFT, we get a customer factor, and also a luck factor. So either way, there's a lot going on here, and it's difficult to tell what is actually slowing down our app and causing performance issues. To add some observability, we could write a trace function that looks a bit like this. The idea here is that our trace function will output the function's name, arguments, and how long it took to actually execute said function. Here's what the output of our trace function might look like if we applied it to this add function that we just wrote. We can see the function name, arguments, and execution time are all logged out. Using the output from our trace function, we can create a heat map like this and identify some performance bottlenecks. This is a bit reductionist, but this is essentially what all the observability vendors out there do. So going back to that trace function code, let's walk through it quickly. And as a side note, this is not real code. It's not production ready. Please don't actually use this trace function code. There's better examples out there that are just a little bit longer. With that said, we're essentially using the performance API to track the execution time of the parameter fn, the function that we want to trace, that's passed into our trace function. Our performance entry is marked as function invocation, and our function execution time is just the duration of this performance entry. So we have our trace function. Things are looking good, but honestly, it seems pretty annoying to change all of our code just to add some observability. To get around that hassle, we're going to use the decorator pattern to selectively attach instrumentation to certain functions. The decorator pattern enables us to wrap objects and attach new behavior to those objects. We'll use a decorator to annotate or mark which functions, that is the object, should be instrumented, that is the new behavior. So TypeScript has had decorators for quite a while as an experimental feature. If you folks have used Angular before, they're all over the place. For the TypeScript phobic among us, I know there are a few of you, there's a TC39 proposal for decorators in stage 3. That being said, we're going to take a look at the next few examples using TypeScript. There's a few different ways to use decorators in TypeScript, and we're not going to get into all of those ways. Let's walk through a straightforward case of using a method decorator. There's other kinds of decorators like class decorators and so on. In this case, we'll attach the logger decorator to a method by using the @ symbol syntax. In this case, it's attached to method 1 in class 1. The logger function itself is a function factory in that it returns a function. Let's take a look at the parameters of that returned function. In this case, target is the prototype of the class the decorator is attached to. We're not going to use target right now, so no need to worry about that. Property key is the name of the method, which is method 1 in this example. And descriptor describes the property itself, including its value, whether it's enumerable, and so on. In this case, it describes method 1 in class 1. We'll use the value property within descriptor to modify or attach behavior to a method call. Let's take a look at what the equivalent of our trace function from before looks like as a decorator. When our trace decorator is attached to method 1, it'll log out its name, arguments, and execution time. We had other methods inside of class 1. We could add the trace decorator to those. If we had other classes, we could add the trace decorator to them as well. We're modifying the method the decorator is attached to. In this case, method 1 in class 1, by actually setting the value of the descriptor parameter. This code, the rest of it, is just very similar to our trace function code from before. It measures the execution time of the attached method and also logs out its name and its arguments. In our example, we attach instrumentation, that is a new behavior, to certain functions by using a decorator. As soon as we're done, we can simply remove it through a one-line code change. That is, decorators are easy to remove. So at this point, we identified the performance issues, go us, we fixed them, everything is great. Turns out, though, we need to add caching, which is going to be an adventure. As a candidate for adding caching, let's take a look at a different function that might be in our code base. We have this getFavorites function. For a given user ID, it returns that user's favorited NFTs, does a bit of transformation, all that good stuff. Essentially, we're fetching some data from our database before we transform it slightly. Let's figure out how to cache the getFavorites_from_DB method, and we're going to do it in such a way that we can add caching anywhere in our code base. To add this caching, we're going to use the proxy pattern. It's going to help us implement this caching and add it anywhere, not just in that one method. The proxy design pattern allows us to control access to an object. We can perform some action before or after accessing said object. For example, we could substitute one object for another. The idea here is that we'll use a proxy to return a cached value for our users' favorited NFTs. We can use the built-in proxy object in JavaScript to help us implement this pattern. It allows us to redefine operations like getting, setting, and defining properties. The syntax for proxies is a bit hairy, so why don't we walk through it together, and we'll take a look at a few small examples. So to start off with, we need to actually decide what we want to create a proxy for. That first argument when creating a proxy is a target. It's the actual object you want to proxy. In this case, to keep it simple, we have this hard-coded object with 4 properties. The second argument to our proxy creation is a handler object. Within the handler object, we can define which operations should be intercepted and what the intercepted operations actually do. There's a few different handler functions out there, or traps. Here we're using the get trap to intercept getting a property value. Our get trap uses the nullish coalescing operator to return null or undefined if the value of the access property is null or undefined. So prop2 and prop3 are null and undefined respectively, so accessing them will return that string null or undefined. Prop1 and prop4, on the other hand, aren't. For those, the values themselves are returned. So let's take a look at another example. And this time, we're going to be proxying a function instead. And we'll walk through this code together too. So in this case, right, our target is our add function from before. Functions in JavaScript are objects, so this is totally fair game. This time, we're using the apply trap for intercepting function invocations. Note how target is a reference to our proxy function. We can access the function's name and any arguments that were passed in to log them out or manipulate them somehow. Here, we're going to keep the proxied function's original behavior by invoking it with the apply method. And honestly, just to keep it a little bit interesting, we're going to introduce a nice off by 1 error. So anytime anybody decides to add 10 plus 20, it's going to be 29 instead. So our original goal was to cache some function calls. Let's get back to it. And here's what it might look like if we implement it with a proxy. There's a lot of code up here, but we'll go through it and take it step by step. In this case, we decided to cache math.random, just to keep it spicy in our code base. No matter how many times we invoke our cache function, it'll always return that same initial value. We're using the apply trap again because we want to intercept function invocations. We want to cache these functions, so we're going to intercept any function invocations. This means we can invoke our function when it hasn't been cached for a given set of arguments. We have the arguments passed in, and we'll invoke the function with those arguments and the correct value of this keyword and all that good stuff. Taking a step back, for the actual caching itself, we're storing the cache return values and its arguments by using a map object. Using a map object keeps our example simple. In reality, we might use Redis or memcache instead. We'll check if we have a cache entry for the function itself. If not, we'll make one. For a given arguments list, we'll also check, is there a cache entry already? If there isn't, we'll invoke the function and also set the cache entry for that argument. We definitely need to actually return the actual value from invoking our target function. To keep it simple, we'll always get it from the cache. Here's what using our create cache function might look like. We invoke it and use the cached version of our getFavorites_from_db method inside getFavorites. Note that we can use create cache function within any of the functions in our code base, not just this one function right here. So things are looking good. We added caching. Our store is actually usable. People are buying NFTs. Our sales are up 10,000%. Unfortunately, our CEO now wants to duplicate NFTs. We suspect that they might not actually understand how all this works. And in silent protest, we decided to delay the duplication work by refactoring everything. From the good old days, we finally remember using our friend jQuery. Look at this. This is pure joy. This is great. This is method chaining. In all sincerity, more recently, we may have written similar code when using a query builder like connects. Notice how the methods here are all chained one after another. Also, notice how the code reads like its own language. Both jQuery and connects have implemented a fluent interface. Implementing a fluent interface involves creating an API that relies on method chaining. The methods themselves also resemble a domain-specific language, or DSL. Let's take a look at what it takes to implement a simple Fluent interface in our code base. We're chaining method calls on item 1. It looks like a language, and that's easy to tell that we're setting the name and then the price. We're able to do so because our setPrice and setName methods always return a reference to the instance of item via the this keyword. Going back to our CEO's ask, let's take a look at what duplication might look like. We decided to name the method clone just to spite them. We didn't call it duplication. It's OK. Honestly, the code itself is not too bad if we use the built-in structured clone method. It's honestly a really neat method. It deep clones a given object, and it can also handle circular references. Item 2 is cloned from item 1 and has the exact same properties. Yet notice how item 1 and item 2 are two different objects as well. All right, at this point, we've covered all of these design patterns. We went through feature flags, singleton, decorators, proxies, and fluent interfaces. Some of them are in the original 23 we saw earlier, but I think that's OK. They're still definitely worthwhile. So what are our next steps? Obviously, the next step is to do this at work next week. Or, you can start right now. Just pull out your laptop, get on the Wi-Fi. I'm kidding, but I'm only kind of kidding. Besides actually trying these patterns out when the problem suits them, which is what I encourage you folks to do, I'd also like to ask all of you to consider if you prefer just-in-time or just-in-case when it comes to learning. The just-in-case folks proactively learn something in case they need it. The just-in-time folks, on the other hand, learn something only when they need it. I think this is important, especially when it comes to somewhat dry and complex topics like design patterns. I would argue that neither side is necessarily better, but it's worth knowing your bias. Either way, I'd like to encourage everyone to try the opposite for a bit. If you're a just-in-time person, why not proactively read a book related to a technology that you use? If you're a just-in-case person, why not hold off on reading until you encounter a problem? Honestly, just write some code and get started. With all that said, thank you folks so much. I hope you all have fun using design patterns at work next week. You have my permission to blame me in your pull requests if your coworkers get mad at you. Feel free to come find me after if you have any questions, and thank you all so much.
Dope.